Article 680.62 C of the National Electrical Code addresses bonding requirements for permanently installed pools, spas, and hot tubs, including the size and type of bonding jumpers. This specific requirement states that the bonding jumper must be a solid copper conductor and it can be insulated, covered, or bare. Crucially, it also stipulates that the bonding jumper must not be smaller than 8 American wire gauge or AWG. The American wire gauge, often abbreviated as AWG, is a standardized wire gauge system used predominantly in North America for the diameters of round, solid, non-ferrous, electrically conducting wire. Wire gauges are specified in AWG sizes, which are integers. Smaller AWG numbers denote wires with larger diameters, which means the wire has a greater cross-sectional area and thus a lower electrical resistance. Conversely, larger AWG numbers represent wires with smaller diameters. The requirement for a minimum size of 8 AWG is based on ensuring adequate conductivity to safely carry fault current. In electrical systems, bonding is the practice of intentionally connecting metallic parts that are not designed to carry current, but which may become energized during a fault condition. The purpose of bonding is to create a low impedance path for fault current, which facilitates the operation of overcurrent protective devices such as circuit breakers or fuses. When a fault occurs and a metallic part becomes energized, the fault current will flow through the bonding system back to the source. This high current flow will cause the overcurrent protective device to trip, quickly disconnecting the circuit and preventing electrical shock hazards. Using a bonding jumper smaller than 8 AWG can compromise the effectiveness of the bonding system. A smaller wire gauge has a higher resistance, which impedes the flow of fault current. This can result in a slower response from the overcurrent protective device, increasing the risk of electrical shock or fire. The code specifies that the bonding jumper can be insulated, covered, or bare. An insulated bonding jumper is covered with a non-conductive material such as plastic or rubber. This provides protection against accidental contact with other conductive surfaces and helps to prevent corrosion. A covered bonding jumper is similar to an insulated jumper, but the covering may not provide the same level of protection against electrical shock or environmental factors. A bare bonding jumper is not covered with any insulation or protective material. While a bare bonding jumper can be used, it is important to ensure that it is protected from physical damage and corrosion. In damp or corrosive environments, an insulated or covered bonding jumper is generally preferred. The reason that a #6 bare wire is non-compliant is because of the red tag that was given. This indicates a violation of the electrical code. The inspector likely cited the incorrect size of the bonding jumper as the reason for the violation. Although the wire is bare, the minimum size must be followed. To rectify the situation, the #6 bare wire needs to be replaced with an 8 AWG or larger solid copper conductor that is either insulated, covered, or bare. The choice of whether to use an insulated, covered, or bare conductor will depend on the specific installation conditions and local requirements. In some jurisdictions, an insulated bonding jumper may be required for all installations. The bonding jumper must be properly connected to all metallic parts of the tub structure, including the metal frame, pump housing, and any other conductive components. The connections must be made using approved bonding methods, such as bonding lugs or clamps. It is important to ensure that all connections are tight and secure to provide a reliable electrical path. The use of a #6 bare wire as a bonding jumper on tubs does not meet the requirements outlined in the National Electrical Code, specifically Article 680.62. This article mandates the use of a solid copper bonding jumper, insulated, covered, or bare, with a minimum size of 8 AWG. The code requirements are in place to ensure electrical safety and prevent potential hazards associated with faulty bonding practices. When installing or modifying electrical systems, it is crucial to adhere to all applicable codes and standards. These codes are developed by experts in the field and are designed to protect people and property from electrical hazards. Failure to comply with these codes can result in serious consequences, including electrical shock, fire, and property damage. Electrical bonding is an essential safety measure that helps to minimize the risk of electrical shock and fire. It creates a low impedance path for fault current, allowing overcurrent protective devices to quickly disconnect the circuit in the event of a fault. Proper bonding is especially important in wet environments such as bathrooms and swimming pool areas, where the risk of electrical shock is higher. The requirement for a minimum size of 8 AWG for bonding jumpers is based on the need to provide adequate conductivity for fault current. A smaller wire gauge has a higher resistance, which can impede the flow of fault current and slow down the response of overcurrent protective devices. This can increase the risk of electrical shock or fire. The choice of whether to use an insulated, covered, or bare bonding jumper will depend on the specific installation conditions and local requirements. An insulated bonding jumper provides protection against accidental contact with other conductive surfaces and helps to prevent corrosion. A covered bonding jumper offers similar protection, but the covering may not be as durable as insulation. A bare bonding jumper can be used if it is protected from physical damage and corrosion. When connecting bonding jumpers, it is important to use approved bonding methods and ensure that all connections are tight and secure. Loose or corroded connections can increase resistance and compromise the effectiveness of the bonding system. In addition to the bonding requirements for tubs, the National Electrical Code also includes bonding requirements for other electrical equipment and systems. These requirements are designed to ensure that all metallic parts that could become energized are properly bonded together and grounded. Proper installation and maintenance of electrical bonding systems is essential for electrical safety. It is important to consult with a qualified electrician to ensure that all bonding requirements are met and that the electrical system is safe and compliant with all applicable codes and standards. When working with electrical systems, it is always important to take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment such as insulated gloves and safety glasses, and use insulated tools. Never work on electrical systems while they are energized. Always disconnect the power before working on any electrical equipment or wiring. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to do the job safely. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC is adopted by many jurisdictions in the United States and is used as a basis for electrical codes around the world. Understanding the NEC is essential for anyone who works with electrical systems. It provides guidance on a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. The NEC is a valuable resource for electricians, inspectors, and other professionals in the electrical industry. By following the requirements of the NEC, you can help to ensure that electrical systems are safe and reliable. In conclusion, Article 680.62 C of the National Electrical Code clearly states that the bonding jumper for tubs must be a solid copper conductor, insulated, covered, or bare, and not smaller than 8 AWG. Using a #6 bare wire as a bonding jumper does not meet these requirements and can result in a code violation. To ensure electrical safety and compliance, it is essential to use the correct size and type of bonding jumper and to follow all applicable codes and standards. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. Remember, safety should always be the top priority when working with electrical systems.